because a square minus x square here also. We have a square minus x square. First step will be 0. Second, this is 0 and this x cube. But this under root a square minus x square is in the denominator. It cannot be 0 because then it will be infinity, not defined. For this x equal to a is not possible. This is not possible. X equal to half only possible because then the solution in the denominator can be calculated. So let me find out final solution. What is that? So this value we have calculated. Let me check what is the final solution. It is negative or not. So this will be minus 3 into k into x is 1.2a or a upon 2. In the bracket it is a square minus a square upon 4 because half of x is half a square is a square upon 4 minus 3k. In the second bracket it is twice xa 2 into x is a upon 1.2a into a square is it means a cube minus this is 4x cube 4x cube, that means x is 1.2, it will be into 1.8 a cube. 1.8 a cube means half a cube. This 2 to cancel out. Okay, this is negative throughout. This value is already negative, this minus sign. This is minus 3k 3 upon 2 into ka. The bracket is 4a means 3a square upon 4. The first bracket minus 3k within bracket it will be 1.2 only 1.2 a cube. This is a cube this means 1.2 a cube. Solution is 1.2. So all are negative. It is less than 0 throughout. Well, it is in terms of a and k constant. So this is less than 0. It means stiffness is maximum. Stiffness is the stiffest when x equal to half. X equal to half is possible. Or x equal to half, the stiffest beam can be cut from this log of diameter A. That is there. Okay, so half of the diameter, the side must be the breadth must be. So breadth must be half of the diameter. That means x equal to the breadth, which we have taken as x, must be half of A, half of the diameter. That will be the stiffest beam possible. So let me take the 9th question and 10th. The 9th question says, question 9 says that show that the volume of the greatest cylinder which can be inscribed in a cone of a height h and semi-vertical angle alpha is this 4 by 27. Volume of a cone, this is cone, so that the volume of the greatest cylinder which can be inscribed in a cone. Okay, again cone, this is the cone here. Okay, and this is the cylinder. Let me take the cylinder here like this, and this is the cylinder of a radius r we take. This is the height of this. Let me take height of the cone as well. Okay, so this is the cone here. Let me take ABC cone. This is O. This is O dash are taken here. This is O capital. Okay, and this O B C D. Let me take this D. This is E here. O I have taken here. Only angle is alpha here given to us. Okay, so semi-vertical angle is alpha. So that the volume of the greatest cylinder which can be described in a cone of height h and semi-vertical angle, this is the volume. So that the volume of this, the greatest volume is volume we have to find out. To prove that volume is, to prove that volume of the cylinder is 4 by 27, 4 upon 27 pi into h cube, pi into h cube tan square alpha. Tan square alpha. This is first equation. We have to prove here. Okay, this is 4.27 pi h cube into tan square alpha. this is the volume of this cylinder. It is cylinder in it. Okay, and instead of a cone of height h, height of the cone is given to us h. AO here is small h given to us. Okay, small h is given to us. Other thing, where the greatest volume can be instead of a cone of height h and semi-vertical angle alpha. Only these two things are given, height and semi-vertical angle alpha. Okay, so let me take the height of the cylinder is h dash. In terms of h, we take height of the cylinder is small h. This is h dash. Okay, this up to this point, the vertical height of the cylinder. Let me take r is the radius. This is r, the radius of the cylinder. Capital R again is the radius of the cone I have taken here. Okay, so then now in place of only h, in terms of h we have to find out the value. Okay, we have to take this right again these two triangles. This is right triangle. The two triangles are similar. Okay, so let here ABC is the cone and this is E. Let me take here EDFG. EDFG is the cylinder, the right circular cylinder. The right circular cylinder is the right circular cylinder. Okay, inscribed in the cone. Inscribed in the cone of height h. Height, and height is AO equal to h, and semi-vertical angle and of semi-vertical angle, vertical angle alpha. Semi-vertical angle is alpha and height is capital small h. This is given to us. Everything we have to convert into alpha angle in terms of alpha angle and h is small h. Okay. So volume of the cylinder we have to find out. What is the volume of the cylinder? So volume of the cylinder is V is equal to pi r square into h. This is small h dash. R I have taken radius of the cylinder here. Okay. This is the value. Now r and this is small h. Now this height is even only in this triangle. No need of taking this r capital. No need of taking r. Okay. Only small r. So value of h dash in terms of alpha we have to find out. Okay, or height of this cone. So this height in this right triangle. What we have r, small r we can calculate. Small r here in the right triangle. Let me take in a right triangle AOD. We have, okay, this is 10 alpha, or this value is, let me take AO equal to AO dash. AO dash equal to AO minus OO dash. And got this point? This is AO is the small h, height of the cone, minus OO dash is height of the cylinder. So AO dash is h minus small h. This is given to us. I mean, this we can calculate. AO dash h dash. Okay. Now in this value, this is h minus h dash. In triangle AOD, we have AO dash equal to AO dash O dash. O dash here. Point. AO dash is equal to AO minus OO dash. That means h minus small h dash. Small h dash is height of the cylinder. Small h, this is given to us, is the height of the cone. Okay, this is small h minus this height of the cylinder is equal to this value AO dash. AO dash is h minus small h. Okay, this value is given to us. We have to calculate this, and this is small r. R, and because r we have to substitute here in terms of h. or h dash also we have to substitute. Let me find out what is h minus h dash. So h minus h dash, or let me take in triangle this. So in triangle, right triangle AOD, we have AO, sorry, this O dash D, DO dash upon AO dash, okay, this O dash D divided by this. This is the side opposite to the angle is perpendicular. This is the base. This is hypotenuse. No need of hypotenuse here. O dash D upon AO dash is tan alpha. This is tan alpha. What is O dash D? O dash D is radius R. Radius R upon this AO dash, we have just calculated h minus small h dash equal to tan alpha. Okay, so this is tan alpha. So R upon h minus h dash is. So let me calculate this R. Okay, if I substitute R here, that can give us, or R square. Okay, h dash let me calculate in terms of R and A. That will be okay. So that let me multiply here. R is equal to here h minus h dash into tan alpha. Okay, that is tan square alpha. If I substitute in place of R here into h dash is also there. So h dash can be then, okay, h dash is to be calculated. So let me take h dash here. It will be h dash into tan alpha. Okay, so that is equal to R minus h into tan alpha. This h into tan alpha I have taken to this side, so R minus tan alpha equal to, sorry, let me multiply them. R, we have obtained h into tan alpha minus h dash into tan alpha. Okay, so this h dash let me calculate. Take this h dash to this side. It will be h dash into tan alpha is equal to h dash into tan alpha equal to h dash alpha equal to h tan alpha minus R. Okay, so in place of this we can calculate this value. Let me write here. So therefore h dash equal to h tan alpha minus small r upon h upon tan alpha. This is the value of h dash. In place of h dash we can substitute this volume of the cone here. So volume of cone will be then in terms of h and r only of tan alpha. Okay, so let me substitute this value. This is first equation. Let me take this as second equation. So from first and second, let me now this is introduction to this question. So v equal to pi r square h dash. That means v equal to now pi into r square. H dash is this value. H dash is h into tan alpha minus r divided by tan alpha. Okay, this is tan alpha. What do we get here? Now let me differentiate dv upon dr with respect to r here. Okay, so that can be then solved further. So this is volume of the cylinder. Volume of the cylinder here it says, assuming that the, okay, this one, so that the volume of the greatest cylinder which can be inscribed in the cone, volume is greatest. This is what we term cylinder. So differentiating this first thing, this second equation. Now differentiating second with respect to x, or with respect to r here, we get, let me change it. Okay, so this is dv upon dr. dv upon dr equal to, this is first step is, okay, let me write it as pi into r square ddr. It's still r not differentiated. I've written it inside. It will be h minus tan alpha cancel out first one. Second will be pi into r cube upon tan alpha. This is the value here. Okay, Now it has to be differential. This is pi r square into h tan alpha upon tan alpha. Tan alpha cancel out first one. This is pi r square into h minus pi r cube upon tan alpha. This can be differentiated now. Let me differentiate this. Okay, anything required here, dv upon this we are just calculating. This is maybe value of h dash. Okay, that is there. So now let me differentiate this. This will be, because this is with respect to r, this will be 2 pi r into h minus, second this differentiation is 3 into pi r square upon tan alpha. Okay, this is dv upon dr. So volume will be maximum for maximum and minimum. Again for maximum and minimum, this dv upon dr must be 0. So this implies that this whole value 2 pi r into h minus 3 pi r square upon tan alpha equal to 0, or pi cancel out, r and h relationship we have to find out. Okay, so we have to find out in terms of r and h, or value of r in terms of h. So this is 2 pi r into h equal to 3 pi r square upon tan alpha. What is cancelled out? Pi cancelled out. R is cancelled out. Okay, so this will be h tan 2h into tan alpha is equal to 3r, or r equal to, r is equal to here, r equal to 2h tan alpha upon 3. Okay, this from this one, this is 2h tan alpha equal to 3r. We have obtained from this after cancelling this, after cancelling them. Okay, cancelling pi 1r, because it's r square, cancel out, tan alpha will be there. So tan alpha cross multiplication, 2h into tan alpha equal to 3 into r. Okay, r equal to, in terms of h we have calculated. Now let me find out second derivative, whether it's maximum or minimum. That is to be done differentiating this equation. This is second equation. Okay, this is third one. Second after third one. Differentiating third, again differentiating third with respect to r, we get, okay, for this d square v upon dr square. This one d square v upon dr square is equal to, first one is 2 pi h only, because we are differentiating with respect to r. R is 1 here. This is minus 6 pi into r. R square is 2 pi r, so 2r. This is 6 into pi r divided by 10. Okay, so this, let me substitute that value, r equal to that value. Is it negative? If it is negative, then we can say that yes, the volume is negative. That means the volume will be maxima will lie there. This is 2 pi into h minus, this value is 6 pi. Okay, this is 6 pi. This value is 6 pi into r is this. Okay, this is 6 pi into r. R is 2h tan alpha upon 3, or this tan alpha is already there. Tan alpha cancel out. 3 2 is 6. This is 4 pi h. 2 pi h minus 4 pi is 4 pi h. The difference is negative, minus 2 pi h. This is less than 0. Because h cannot be negative. H is height cannot be negative, and pi is constant, so it is negative. That means volume will be maximum. Okay, so volume will be for maximum volume, r must be this. What is the maximum value of the volume? That we have to calculate now. Okay, the maximum volume in this case will be this value. R I have to substitute in terms of h. So this is the final volume which we obtained here, this much. Okay, this value, because we have not differentiated this, is still value of R. If I substitute and solving it, can give us the final value. So let me substitute R is equal to. So here R is equal to twice H tan alpha upon 3. For this value of R, the volume must be maximum, which we have proved here, because this is less than double derivative is negative. Double derivative is negative, that means maximum will lie. So maximum volume will lie if the volume is, let me solve it. So what the value of then finally volume? So therefore volume V, which is given here, this is pi into R square H. This I have solved from this one. Pi R square into H minus pi R cube upon tan alpha. Let me further solve it. Pi R square can be taken common from both of these. Pi R square are taken common. Okay, this is H in bracket minus 1R upon tan alpha. Okay, now substitute the value of R here. This is this. Even inside, if R I have to solve, let me further solve it. Pi into R square. The outside R I have still not substituted. So this is H minus R is this. Is twice H tan alpha. So tan alpha divided by, this is tan alpha already there. 3 into tan alpha. Tan alpha cancel out. Is 2 by, okay, 2H by 3. This is pi into R square. Within bracket is 3H minus 2H upon 3. So this we have obtained here, pi into R square. Within bracket it is H upon 3. Okay, 2H, 3H minus 2H, that means H upon 3. Now R to substitute R square also in terms of H. So let me finally substitute the value of R, which is this much. And this also I substitute inside the bracket. Inside the bracket I have solved this H by 3. H by 3 we have obtained, because the answer must be in terms of H and tan alpha. So let me substitute R here. Finally the volume will be, let me substitute this here. So this value is equal to pi into R square, sorry. So R square, this R square means square of this, that will be 2H into tan alpha upon 3 whole square into H upon 3 is also there. Let me solve it further. Let me write it here. So this will be V is equal to volume is equal to, let me write it under answer here. So therefore V is equal to pi into, this is 9 in the denominator is square of 3, and this 3, so 27. 27 will be there, H square and H cube is there, okay. 10 square alpha is there. So this is 2 means square 4. 4 pi upon 27. This is 2 to the 4. 2 square 4. Pi is out of this bracket. This is H square and H is HT. Okay, and this is 10 square. So final answer is this value, which we have to prove. Okay, we have to prove that volume is this one, 4 by 27. 4 by 27 pi, okay, into H cube to 10 square alpha is okay. This is the final answer here. Final answer is obtained as volume of that for maximum value of H. Okay, for maximum value of maximum volume of volume. Okay, maximum volume. Okay, and for the given height of the cone and given this alpha angle, semi-vertical angle, the value, the volume must be maximum. For that, what is the value of volume? Okay, in terms of H angle. So this is finally 9th question is done. Now let me take the final question. 10th one. What does it say? Now question number 10th is regarding what? Question number 10th finally is it says that tangents are drawn to the ellipse, okay, of x square upon a square by upon b square 1, and the circle x square plus y square upon equal to a square at the points where a common ordinate cuts them so that if theta be the greatest be the greatest inclination of the tangents, okay, then tan theta equal to this. Let me first draw that what is the circle, ellipse and circle. So let me take a circle and ellipse. This is the circle here, okay, and this is the ellipse. I'm sorry, this is the ellipse here. Okay, this is the ellipse here. So if I take the tangents, it says the tangents is drawn, okay, to the circle, and this is the tangent drawn to the, okay, cone. And if I take, let me write this here. This is the tangent here, and this is tangent to the ellipse. This is the angle theta here. It is given to us. The tangents, angle between the tangents upon ellipse as well as this. And it says that common ordinate. Let me take this is the okay, angle is the center of the ellipse as well as of circle, and this is epicenter. Okay, or equal or center is the same, equal center. This is O here, equal center. And if I draw, let me take this is the currently x-axis. This is origin O, which I have taken already, and this is the axis of y. Okay, and the ordinate says common ordinate. Let me take common ordinate is the common ordinate cuts at the tangents at point P and Q. Let me take this Q point here. P and Q point, P point is on the circle and Q point is on the ellipse. Okay, and if I draw angle, let me take then angle. Okay, this is the common angle, and if I take this angle to this also, this angle is phi angle. We know that this angle phi, in case of when they are similar, I mean this angle will be the same. PO, let me take here any point. This is capital B, this is capital A. Okay, so this angle POB is phi angle. Let me take. Okay, this phi angle is not given to us, but the tangents are drawn, okay, to the ellipse, and theta we have taken here, so this is phi angle. Okay, so what are the points on the Q point, and this is common ordinate, which takes this. Common ordinate cuts these two tangents and circles. So what are the points here? Let me take here. This is B. Okay, this is x square upon a square equation of the ellipse upon y square equal to 1. Okay, so this point will be B ordinate, because this is the B ordinate here. This is A, this is B ordinate. So this point will be, or A will be A, this base will be A into cos, A cos phi, this is B sin phi. These are points of Q point, and this is A sin phi, because the radius of the circle is, this radius of the circle is A. A sin phi, sorry, A cos phi, because A cos phi the base, and this is A sin phi of the circle. The points, the coordinates of the point P are A cos phi and A sin phi. Coordinates of the points on ellipse is A cos phi, and this is B sin phi, because B is the this ordinate here. In terms of B, we have calculated this point here. This is phi angle. So this is A cos phi and B sin phi. The side is in terms of ordinate. So what are the tangents drawn upon these two. Let me find out differentiation of this. What the derivative of this point here? Differentiation of this and differentiation of circle. The equation of the circle. Let me write equation of the circle is x square plus y square equal to a square. It is a square. X square by square will be a square. So a is the radius of the circle. This is a here. Complete. Okay, so this is a cos phi for this, and this is a cos a sin phi. A sin phi is coordinates of this. But in this case, it is b height of the this ellipse. This is b. This is b cos b sin phi. This is a cos phi similar. Okay, so a cos phi is common of P and Q point, but B sin phi and A sin phi are the difference. That is, this is equation number 1, and equation of the ellipse. Equation of the ellipse we are given here. Ellipse is x square upon A square plus y square upon B square equal to 1. Now let me find out. So that this, because angle between them is theta, so both the gradients of the gradient of both the tangents we have to find out. The slope of both the tangents we have to find out. Dy upon ds, m1 and m2. Let me take tangents upon the this ellipse and tangents upon this. So what are the tangents here that we have to calculate? Tangents can be calculated from the equation given here. So let me first solve the equation of this. The differentiating equation is second. Let me first find out circle's tangent. So differentiating first with respect to x there, with respect to x, we get this is twice x plus twice y into d by dx equal to 0. This is d by dx, therefore, in case of circle, is equal to minus 2x upon minus 2y. Sorry, 2y, 2 to cancel out, is minus x upon y. So d by dx at the point given, at the point, what is the point here of circle? A cos phi and b sin phi. What the point here? This d by dx. This is minus x. Minus x means a cos phi upon this is b sin phi. Sorry, a sin phi. I'm sorry. In case of circle, it is a both. A cos phi and a sin phi. Sorry. This is a sin phi. This is nothing but minus cot phi. A cancelled out. This is minus cot phi. This is gradient of slope of the